In this video, I'll cover some specific types of validity. So first, just a quick review that reliability refers to the consistency of measurements, validity refers to the accuracy of measurements. So we've already covered the different types of reliability in the previous video. In this video, I'll be covering specifically the types of validity shown here. Content validity is the extent to which an instrument covers all aspects of the construct it is intended to measure. Does it cover all dimensions of a construct, for example? So anxiety has both dimensions of cognitive anxiety and somatic anxiety. So basically, if we have an instrument to measure state anxiety, does it cover both cognitive and somatic anxiety? So this is also known as logical validity or face validity. And we tend to assess this qualitatively. We just have experts look at it and basically read it and see if it covers all of the sort of theoretical aspects of the construct. Concurrent validity refers to the extent to which a new instrument performs as well as an already established validated instrument. And we can assess this using correlation. Basically, do the scores from the new instrument correlate with the already established instrument. Convergent and discriminant validity are related concepts. So these are the extent to which an instrument measures a construct as similar to constructs that are theoretically related, that's convergent validity, but as distinct from constructs that are theoretically unrelated, so that's discriminant validity. So for example, cognitive and somatic anxiety are related because they're both dimensions of anxiety, but they're distinct dimensions. So their scores, if they're measured with some questionnaire, their scores should, to varying degrees, should be similar but also should be distinct. So they should reflect both convergent and discriminant validity. And we can assess this using correlation. So constructs that are even less related than cognitive and somatic anxiety would be related to one another should correlate even less than they do with each other. Predictive validity is the extent to which scores on an instrument are able to predict some future outcome. And we can use regression analysis, which is a statistical method of prediction, to assess predictive validity. Construct validity is the extent to which an instrument measures the construct it is intended to measure, and we can use factor analysis to assess construct validity. Factor analysis is probably beyond the scope of most master's programs. It's something that would be covered in a doctoral program typically. So it's a statistical method that's a little bit complicated. I'm going to give a little bit of background on it just in the next several slides. So as I said, factor analysis is important for establishing construct validity. It basically helps to assess how do measured variables, which are basically your questionnaire questions, your items on the questionnaire, relate to unobserved constructs. So these latent constructs, they're sometimes called latent factors, these hidden, unobserved constructs that we're intending to measure with a questionnaire. So there are two types of factor analysis. Typically there are exploratory factor analysis and confirmatory factor analysis. So we refer to these as EFA and CFA. Exploratory factor analysis is basically the first step in developing a new instrument. So this will help us to determine how many constructs are measured by a set of items. It will also help us to examine how much each item is related with that construct. So basically what you do is you draft some questionnaire questions, you give it to a large group of people, they basically respond to the questionnaire, and then you can use exploratory factor analysis to help determine how many constructs are you measuring and how well do the questions relate to those constructs. Factor loadings are like a measure of correlation. So they range from -1 to 1, and they basically help us to understand this, again, the strength of how well each question is measuring a construct. So if those factor loadings are large and positive, say greater than 0.4, then we consider them to be pretty strong measures of the construct. So basically at that point, items with smaller loadings would get thrown out or else revised and basically try again. And when you try again, basically what you're doing is confirmatory factor analysis. So here you're basically seeking to understand whether each item significantly loads onto the factor it is hypothesized to load onto. So is it related to the factor it's proposed to be related to? In other words, are the factor loadings large and positive? Are they still greater than 0.4? And how well does the overall model fit with the observed data? And so there are a number of statistics used to assess the fitness of the model with the data in CFA. And some of those are listed here on the screen. So the chi-square goodness of fit, you want to be, it's a hypothesis test, you want it to be non-significant. So you want p to be greater than 0.05. We'll talk more about hypothesis testing later in the course. So if you don't understand this idea right now, don't worry too much. These different indices that you see here, the GFI, CFI, and TLI, you want to be as close to 1 as possible, so greater than 0.95 ideally. And then there are different fit statistics that refer to error. So the root mean square error of approximation is one of those. The standardized root mean residual is another one. Those you want as close to 0 as possible. So in this case, less than 0.08, less than 0.06. You don't have to have these values memorized. I'm just basically showing that there are different ways to assess basically how well your confirmatory factor analysis model fits with the observed data that you collected through the questionnaire. So here's a model diagram. It looks a little complicated, but basically this is a model diagram for the Beck Depression Inventory 2. So what you can tell from this diagram is that there are 21 questions on the questionnaire, basically looking at different symptoms of depression. So the first one is about sadness, the second one's about pessimism, and so on. And those first several are types of cognitive affective depression. And then there are somatic measures of depression, so things that are more like physical symptoms like loss of energy, loss of sleep, feeling irritable, loss of appetite, things like that. And then basically all of them are all of them would load on to this general factor. So there are some that are specifically cognitive affective, there are some that are specifically somatic, and basically all of them taken together are considered to be general measures of depression. Here's a model for the GEQ that you're familiar with. So the basically individual attractions to group, social, and task, group integration, social, and task, and recall that each of them has either 5 or 4 questions that go with those dimensions. And basically what you see here are the factor loadings of each of those questions with its sort of broader dimension of team cohesion, how much each of those correlates with one another. So again, I don't expect you to fully understand factor analysis. I just want you to be familiar with some of the diagrams that you might see in articles and some of the different values that you can expect to see in terms of fit indices or factor loadings or things like that, because all of these things are relevant for determining the validity and reliability of your measurement tool. And so some of you might adopt a questionnaire that has already been validated in previous research, and you'll want to be knowledgeable of the different measures of reliability and validity. So that's basically why I'm covering these things. You're not going to be expected to do this type of analysis for yourself. You're basically just going to be expected to choose a valid and reliable tool, and you need to sort of know what you're looking for in these different articles. Here's a table of fit statistics. I'm not sure specifically what it's referring to, but again, just to kind of give you an idea of what you might see in one of these articles. So you have the chi-square value, but you have some of the indices that I talked about that you'd like to be as close to 1 as you can. So ideally these would be higher. And you want RMSEA to be as low as possible. I think I said less than 0.08. So those are looking pretty good. So there are just different fit indices that can be reported. There are many more than I've talked about. So you may see some additional ones in articles. Again, you don't need to be experts on the different ones, just kind of familiar with the different types of them. Some you want to be close to 1, some you want to be close to 0.